Welcome to the second day session of Arduino and IoT webinar. So before starting with the second day, I will recap what we have learned yesterday. So yesterday we have covered about Arduino, the specifications of different boards. So like we have Arduino Uno, Arduino Nano, Curie board, then I have covered many boards in that. Then we have seen the pin configuration of an Arduino. So how the pin looks like, how many pins are there, what are the power section, which is analog section, which is digital section, and which is ground and all. Then we cover some basics about embedded system, embedded C programming. Then we cover basics about some interfaces and how you can program through online compiler and how you can program through the regular compiler. Okay, so we'll start with the second day session. So first of all, with the second day session, we start with button interfacing with Arduino. So as button is an input device, so it's required to connect the button with two different configurations. Like there are two configurations, like one is pull up configuration and second is pull down configuration. In case of pull up configuration, so the configuration looks like this. So we have a VCC. Then there is a pull-up register. So you can use either 10K of pull-up register. Then the output is taken out from the center and the button is there. So when user presses the button, it provides the 0 output. Whenever button is released, it provides the high output. So under a pull-up configuration, when button is not pressed, it provides high output. When button is pressed, it provides low output. This is about pull-up configuration. Second configuration is pull-down configuration. Again, VCC is there, button is at the top side, and then 10K register at the bottom hand side. Then when you release the button, at that time it provides 0, logic low. When you press the button, at that time it provides logic high, that is VCC. This is pull down configuration. So you can use any of the configurations with the Arduino, either pull up configuration or a pull down configuration. So we need to configure that particular thing in a program, whether you are going to use a pull up configuration or a pull down configuration. Next, so there are two different perspectives of current sourcing and syncing with the Arduino digital interface. So what do you mean by current sync and current source? So this figure represents the current syncing. In this case, I have attached one LED with the digital pin. So you can consider any of the digital pin, and the LED anode is connected to source, that is plus 5 volt. And the cathode is connected via register to the digital input. So current syncing is always better because your controller has to sync the current and it has passed through a ground. No need to source the current. When in case of a sourcing of a current, your controller has to source the current and then it has to drive the LED. So each and every controller is having limitation over the sourcing of a current, and due to the heavy sourcing of a current, the controller gets heats up. So if you want to run your program long life 24/7, so if possible, better to choose current syncing configuration instead of current sourcing configuration. This is a program now, button and LED interfacing. So here, so instead of this diagram, I will open the code and explain the code there. Here is the program for button and LED interfacing. So with this first line, constant int button is equals to 3. So is assignment for the button, like definition of an variable button is equals to 3. So I'm going to connect button to the pin number 3. Then LED is equals to 2. I'm going to connect the LED to pin number 2. Void setup. So setup means it will configures the pin mode, whether that pin is input pin or output pin. As we have seen yesterday, the pin mode button is always an input, so we have configured as an input, and pin mode LED as an output. So LED is output device, so we have configured as an output. Under loop is like same as that of a main, so it continuously execute this particular loop. So I have taken one variable, that is button value. So whatever the button value, it will read from the hardware and it will saves into this button value. How to read that button? So there is a function known as a digital read. So this digital read function will read this particular button. So button is connected to pin number 3. So it's going to read the pin number 3 and it saves that value into button value. If button value is equals to 1, I have configured the button in pull down mode. So if button value is 1, it's going to turn on the LED, and digital write, it will write some value onto the LED pin, that is pin number 2, and then it will write high output there. It will wait for 2 seconds. If not, like if button is not pressed, then it will write low signal on that particular LED. So LED is off that case. So we'll see the simulation now, how the simulation looks like. So before going for the simulation, I will compile this particular code. So in this code, as we write a delay in both the if loops, what happens whenever the controller is going to execute the delay routine, whenever it is in delay routine, it's not going to check this particular button. So once the user presses that button within this 2 seconds, it's not going to recognize that particular button. So this is the limitation, or this is drawback of this particular code. So to overcome this drawback, we need to learn about the interrupt. So after the sessions, we'll learn interrupts as well. So it's compiled. Now I'm going to copy the hex file. Again, yesterday I have explained how to copy the hex file. So we need to select this particular file. It's selected. Sorry. It's selected. Just copy it. Go to your Proteus design. Double click on this chip. Double click on the data file as well. Delete it. Paste it. Click OK. You can see here it is a pull down mode. So button is connected with the +5 and 10K register is there. Then that input is given to pin number 3 and LED is connected to pin number 2 via 330 ohm, that is current limiting resistor, and the LED is connected. So again LED is in sourcing mode and button is in pull down mode. So if I run this particular thing, you'll observe the thing, it's running now. So this input is 0 now because this is not, circuit is not completed. Once I press the button, the circuit gets completed, like current flows from this to this side. So you can on it. So button, once I press the button, LED is on. Once I release the button, after 2 seconds, it's going to off. Once I press it again, it's on. Again, if I release, it's off. Now, if you want to see the current directions, I can turn on the current directions from here. So for that, I need to stop the simulation. Go to the settings, system, go to the animation option, then show wire voltage and color by the color. So it's going to show the circuit. The circuit is not completed now. Once I press it, the circuit gets completed, the LED is on. Now if you want to observe without delay, so we'll remove the delay and we'll observe the things. I will stop the simulation, go to system, animation option, I will remove the animation and I will remove the delay as well. I will comment the delay, /line will comment the delay as well. So I'm going to save it and again I will compile it. So once compiled, the code file is same, hex file is at the same location till you closes this particular window. So if you are not close this window, then your hex file is at the same location. So you can use the hex file as from there as it is. Done compilation. So total bytes of code is 892 bytes. Here 2% of a program storage space has been used. So if I run it now, so I have removed the delay, so you can observe here. Once I press the button, it's going to execute that particular thing. So this is good programming. Okay, so on the actual hardware also it will work same as I have explained with the simulation. So we'll go forward. We'll have some project example. Here we'll do a traffic light demonstration with the Arduino Uno. So I will explain the circuit first before starting with the demonstration and program. So here it is a circuit schematic. So I have pin number 12, pin number 11 and pin number 10. So pin number 12 is connected to red LED, pin number 11 is connected to yellow LED and pin number 10 is connected to green LED. So this is again in a sourcing fashion. So 1K ohm resistance has been connected for current limiting, and then that all the cathodes are grounded through the registers. Here it is a circuit schematic. Again, pin number 12, as I explained, it is connected to stop LED, that is red LED. Again, pin number 11 is just for wet LED, that is orange LED, and pin number 10 is for green LED, that is go LED. So we'll see the demonstration. Now I'm going to explain you the programming of traffic light demo. So here we need to do a repeated task like turning on the green light, turning on the orange light or yield time, or turning on the go line. So red, orange and green, so these are the repeatedly changing. So here the new programming fashion I have used like function, so I wrote different functions for that. So here it is the integer time stop. I will wait for 6 seconds for the stop like red light. I will wait for 2 seconds for the orange light, and I'm going to wait for 6 seconds for the go time. Again, very first thing in the setup, we need to do a pin mode. Again, all the LEDs are output, so we'll do that by doing pin mode 10. Again, red LED, this is for red LED, so I'll put comment there. Then again, this is for orange LED, and this is for green LED. So again, I have made that particular configurations, so 10, green and red. Again, we write a low signal on that, all the 3 LEDs, like 3 lights. Red is off, orange is off, and green is off. In the loop, so this is same as that of my void main. So I have 3 functions. One is for stop light, to turn on the stop light. One other is for go light, like turn on the green light, and third is for turn on the orange light. So with respect to stop light, I am passing the stop time. Stop time is 6. I have defined the stop time at the top. Stop time is equals to 6, so it will take that. Under a go time, again it is 6 seconds. So again go time is 6 seconds. And then yield time is 2 seconds, so it's going to call this particular functions. So we'll see each and every function what is written in that. So this function will take one argument without return type. So stoplight is a function with one argument, it is a time, and without return type. So I will go to the definition of stoplight. So this is a stoplight function, is having one argument as a time. Then digital light, for the stoplight I need to turn on only the red light, so it's going to turn on only a 12 number pin. So 12 number pin is high, both of the pins are low. Again, whatever the time it's going to receive, that is 6 is a unit, so we need to delay for 6000, so time multiplied by 1000, that is 6 seconds it will wait. Again, same for the yield time. Yield light, integer time, again it will receive as an argument. So 10 is low, 11 is high, and 12 is low again. So 2 into 1000 is again 2 seconds it will wait. Again for the go light, it's a green light, again it will take a time. Digital light, 10 is high, that is green is on. Then wait for both the active low for orange as well as red, and again wait for 6 seconds. So we'll compile this particular code and we'll see. Okay, done with the compilation. Yes, it's done with the compilation, no errors, no warnings. Done with the compilation. Then I will need to find the hex file. So hex file is available here. So we'll copy the hex file from here. Copy this particular thing. Go to your simulation. Here I have used traffic light module from the Proteus. Again, red light, orange light, and green light. We'll double click on this. I'll give a hex file here. I will remove this. Click OK for this. Then I can run the code again. You can observe 6 seconds for red light. It will switch to the green light after that. Okay, because I have called the green light after red. Again 6 seconds for green light, and again it will switch to the wait for 2 seconds. Again it goes to the red light. So this is the demonstration of traffic light. It goes on repeating these particular states. Okay, so next is controlling LED with the PWM. So do a silent. So for this controlling LED with a PWM, we are going to use analog write function. So what analog write will do, analog write will writes the analog data onto that particular pin, and because of that we can have like linear change in the values in the with respect to analog. But in case of a digital only we have two states, like either logic 0 or logic 1, but in case of analog we have linear change. So Arduino, as I told yesterday's lecture, the Arduino is having some PWM pins, and those PWM pins will be notified. That is pulse. PWM stands for pulse width modulation. PWM pins will be notified with the tilde sign. So pin numbers are pin number 3, 5, 6, 9, 10 and 11. So these are the PWM pins. So here the schematic we have. I have connected one LED to the pin number 9, and this LED we are going to change intensity of the LED we are going to change based on the analog output. So we will gradually rise or gradually turn on the LED. So 5%, 10%, 20% like this till it's full bright. After that again it will turn off. So I'm going to explain you the code for this. Okay. So to operate the LED with a PWM pin. So here I have assigned LED pin to the pin number 9. So I'm going to connect the LED to pin number 9. Then I have initialized the brightness with 0, and the fade amount I'm going to change with the 5%. So I have written fade as 5. So it changes with the 5%. So again in a void setup, as the LED is output device, so I have made pin mode LED comma output. So pin number 9 is output pin. Again in the loop, this is same as that of a void main. Analog write. So here is the function I have used analog write. Analog write LED comma brightness. So earlier the brightness is 0, so LED is off. Again I'm going to change the brightness. Brightness is equals to brightness plus fade amount. So it's going to, for the next iteration, the brightness is 5. It will write that brightness into this again LED. So next time brightness is 5. Again it will loop it after delay of 30 milliseconds. Again it will loop 10. Brightness is 10 now. Brightness is 20. Brightness is 25. Brightness is 30, 35, 40, so on. So it will go till 255, because I wrote here when the brightness is at 255, that is highest brightness level, it's come down. So I will do brightness is less than equals to 0 or brightness will be greater than equals to 255. This if condition is true, and it will assign fade amount is equals to minus of fade amount. So earlier fade amount is 5, and in this case the fade amount is minus 5. So it will come on reducing the fade amount. So brightness is now 255, 250, 240 and so on. So like this it will decrease and is going to execute this particular code. So we'll see the actual demonstration of this on the PCB. With the protest simulation, if I run, it blinks the LED, but it's not observed as good as, because this is not a real-time simulation. The CPU has been loaded, because for 30 milliseconds we are changing the data. Because of this it's not real time, but we can observe this on actual hardware, real time on actual hardware. We'll see that. Okay, for the real time programming, we'll select go to tools first, then select the board as Arduino Uno. After that again go to tools, select the COM port, as my COM port is COM2. I have selected this again, and I'm going to upload the code. Here it is upload button to upload this particular code. So we can observe the compilation steps at the bottom side here, and once uploading has been done, so it's uploading now. Once upload has been done, it's uploaded. Now we can move towards the hardware side. You can observe the LED is, brightness of the LED is changing. So I will explain the circuit diagram. Here this is pin number 9. Here it is, pin number 9, red wire is connected to anode of the LED, and the cathode is grounded here. Cathode is grounded and the LED is available here. The LED is, brightness of the LED is changing, so I will change the camera side. So you can look at this, brightness of the LED is changing. As we have 30 millisecond delay, so it's going to change within a 30 millisecond delay. Okay, so this is about PWM. Next, PIR motion sensor interfacing. PIR stands for proximity infrared. To detect the motion we are going to use PIR sensor. The PIR sensor allows you to sense the motion. So there are many applications of PIR sensor, like if you want to turn on the light when there is a motion, or if someone enters in the room, it has to turn on the automatic light. So we are going to use a PIR for that. Or there are some applications like we have bank, say locker. If there is a motion detected, it has to turn on the siren. So they are going to use a PIR as well. So what are the advantage of PIR sensor? So it is a small sensor, it's very small in size. Then it is inexpensive, it's a low cost, only 100 rupees cost is there for PIR. It is a low power sensor, it works with just 5 volt. No current boosting or amplifying circuit is required for this. Easy sensor, don't wear out sensor, so it's standalone sensor. Again, they are often referred as PIR or passive infrared. The names for PIR sensor is passive infrared, pyroelectric sensor, or IR motion sensors. So basically the PIR sensor, that is a module, it uses BISS 0001, that is micro power PIR motion detector IC. So this IC is micro power, is a very less amount of power it's required to run this particular IC. We'll see a data sheet of BISS 0001 IC, what is there, why it is known as a micro power IC and all. So I will open the data sheet of this. Okay, so this is BISS 0001 PIR microcontroller IC. Basically it is 16 pin IC. So the pin configuration is here. So it's having A, V0, RR1, RC1, RC2, RR2 and all. So this IC comes with a module. So we'll see power requirement and power call. The power supply required is just 5 volt. The voltage on any pin is either 0.3 or 5 and 6 volt maximum. Operating temperature is, it will works with 0 to 70 degrees centigrade, and storage temperature we can store this particular IC under -65 to 150 degrees centigrade. So power supply minimum requirement is just only a 3 volt and typically 5 volt. Maximum it will run with 6 volt. The current requirement for standby current is 0.9 milliampere only, and typically is 1 milliampere. So it's a very less amount of current it requires. Then operating current, it's 1.8 milliampere, and maximum it's up to 2.5 milliampere only. Again, internally it's having a relay circuitry and all. So we'll see a block schematic of this. So I will rotate this particular thing. Okay, so this is about power supply circuitry. We have here IST7133, that is a power supply which provides you a constant 3.3 volt operating for this particular IC. So this is the IC. Here it is a PIR IR sensor detector circuit, and then we have the output at this particular point. So this much data is sufficient for us. Next, now we'll see internal structure of PIR motion sensor. Basically it's having infrared PIR here. Then it's having one Fresnel lens on the top, and then Fresnel lens is having directivity, so it radiates the like waves on all the directions like this. So this is plano convex lens, that is Fresnel lens is there. So this is actually a infrared IC. Then whenever there is a object, so it reflects the signal back to it and it's detected. Under a PIR motion IC, so it's having one filter window which receives the signal reflected back, and there is one ceramic structure inside it. This looks like this. On the top, this shield is known as a Fresnel lens. There are 2 ports available. One port is for sensitivity adjustment, another port is for time adjustment. So we can adjust the delay, like triggering delay, and we can adjust the sensitivity as well. Also the PIR is very good feature it's having, like we can attach one thermistor here, so it can automatically detect the temperature as well. So RT, there are 2 holes available. So on this particular holes we can attach temperature sensor, that is thermistor. Also we can attach LDR. So LDR is again light dependent resistor, so we can operate based on the light, based on the temperature, and based on the motion. So all the 3 things combined together. But with the current sensor, these things are not available, so these are the optional, so we are going to use it. input stabilizer, voltage stabilizer is available here. Then as we have seen the BISS 0001 IC, that is signal processor. Then we have it can be switched to either active high mode or active low mode. So we can have low and high input pulses here, or jumpers. Some modules are having jumpers here, so we can change either to active high output mode or active low output mode. So there are 3 pins. One is VCC, second is output, and third is a ground. So VCC, either we can give 5 to 20 volt, output is the TTL output, so 0 to 5 volt, and the ground is connected to ground. So this is a schematic diagram. So here the PIR sensor is an input sensor. So we have connected that output line to the pin number 2. VCC is given through VCC, and the ground is connected to a ground. Then LED is connected to pin number 13. So anode is connected to pin number 13 and cathode is grounded here. So we'll see actual live demonstration of this particular PIR sensor. Here is the code for PIR sensor interfacing. So PIR sensor is connected to pin number 2 and LED is connected to pin number 13. So again the same configuration. So here we have read the PIR status. The PIR status, digital read PIR sensor. If the PIR sensor value is 0, it will turn off the LED. If it is 1, it will turn on the LED and it will wait for 2 seconds. So I will show you the circuit schematic. Here actually basically a PIR sensor. Here it is. On the top we have Fresnel lens, and at the bottom hand side we have BISS IC. There are 2 ports. One is for sensitivity adjustment, one is for time delay adjustment. Then you can remove the Fresnel lens. Sorry. And then you can observe the pin configurations here. One pin is VCC output and a ground. So VCC is connected to +5, output is connected to pin number 2, that is input for the microcontroller, and ground is connected to ground pin. And the LED is connected to pin number 13. So if there is a motion in front of this, I will do a motion, the LED turns on. So if I am steady, look at this, it will on for 2 seconds. If I am steady, there is no motion, so it will not turn on. If there is a motion, it's automatically detect the motion immediately, and then it's turn on the LED. Again, if there is a motion, again 2 seconds delay is there. Okay, so just we have seen the interfacing of PIR sensor. The PIR sensor range is up to 15 feet. So technically it's ideally it's a 15 feet range, and the drawback behind the PIR sensor is it can sense any motion directly. Suppose if you have attached the PIR sensor in your parking slot, and if there are some plants and because of air the plant leaves are moving, then only it will detect as a motion. Okay. Next, serial communication. Serial communication is very important point, because we need to communicate different devices with the microcontroller by using serial means. And serial is very popular because it requires very less hardware structure, and we can have acknowledgement over the serial lines as well. So there are different serial protocols, like we have UART, Universal Synchronous Receiver Transmitter. We have I2C as an inter-integrated circuit bus. Then we have SPI, serial peripheral interface. We have SSP, we have Modbus, we have CAN, controlled area network. So many serial protocols are there. So serial is a bit of information. So here actually it's a computer and this is your receiver. So the computer will send the data. This is sender, so it will send a data over a single line, and this data is in the form of bits. Suppose if you want to send 1100 1101, then it will send in the form of bits, and the receiver also receives this particular data in the form of bits. So to synchronize this transmitter and a receiver, there is standard baud rate will be configured first. So what is baud rate? So baud rate is bits per second the transmitter is sending, and at the same rate the receiver has to receive it. There are some standard baud rates: 300, 600, 1200, 2400, 4800, 9600, 1414400, 19200, 28800, 38400, 57600, and 115200. The most popular baud rate is 9600, and in case of IoT or in case of a Wi-Fi communication, we are going to use 115200 because we require a faster baud rate. So there are some standard serial functions available with Arduino IDE. We'll see those standard serial functions. First function is begin. So this function begins the communication. End. This function ends the communication. Available. It is used to get the number of bytes from the keyboard. Read. It reads the input from the serial port. Pick. It returns the next byte of character from the incoming serial data without removing it from the internal serial buffer. So it will find out the next character in the serial buffer. Flush. Waits for the transmission of the outgoing serial data to be complete. So till the serial communication has not completed, it will wait by using the flush as a function. Then we have a print function. It prints all the information over the serial window. Println will print all the information on the serial window with a new line for each and every time it shifts the cursor to the new line. For example, we can print on different number systems as well. Suppose here is the example: serial.print 78, bin. So this prints this 78 values in the binary format. Then we have the example like this: serial.print 78, oct. So this will print that value in the octal format. Again, we have the example gives a decimal. Then we have example which gives hexadecimal. Here serial.println, so it will print on a new line 1.23456. This is a floating point number, but if we use the index as 0, so it will print only a numeric value, that is 1. If you use the index as 2, it will print 1.23, only a 2 decimal places it will print. And if you use as a 4, then it will print 4 decimal places. There is a function known as a write, which writes the binary data to a serial port. Then we have another function known as serial event as well, so which is used for serial interrupt as well. So there are few more functions are there. We'll see those. Here find is there. So we have seen already available, begin and end. Find is there. Find is string. It reads the data from the interface until the specified string is found and returns the true if the string is found. So to find the string, it's going to use a find as a function. Find until the string and the terminal. It reads from the interface until the specified string is found on the terminal, or the terminal string is to be found. Flush, waits until all the data is to be sent from the interface. Parse float, again this is the important function. Parse float, it returns the first valid floating point value from the interface. Then parseInt, it returns the first integer value from the interface. To receive the integer value and to receive the floating point value, this we are going to use as parse float and parseInt. Then there is a pick we have seen now. Print and println we have already done. With this read, it returns the first byte of incoming signal from the interface. Read bytes buffer comma length, it returns the length of bytes of incoming signal into a buffer array, or 0 if no data is represent. Read bytes until character, buffer and the length. So we'll put the arguments for this function as a character, as a buffer and as a length. So it will find it will read the buffer till it finds the character. Set.timeout, so sets the number of milliseconds to wait for the data when using the read bytes or read bytes until function. By default is 1000 millisecond, 1 second, right? Then value. Okay, so we'll see first program, hello world. So I will explain the first program. So here void setup, again it is a setup and loop. There are two functions. So we are going to use serial.begin. This begins the serial, and I am specifying here is 9600 baud rate. Then I'm printing serial.println with a new line. I'm printing hello world. So it will print hello world on the new line. So we'll see on actual hardware. Okay, here we go. Here is the program, void setup serial.begin 9600. Then it will print hello world. So we'll select the port. First I will select the board. I'm using Arduino Uno. Then I will select the port. I'm using COM2 as a port. Then I will upload the code onto the actual hardware. So it will find the hardware, it will build the code. It's compiling, has been done. Okay, it's uploading now. Once it's uploaded, it will display the message done uploading. Then go to a tools. There is an option serial monitor. So click on that serial monitor. You will receive this window. Once I reset the controller, here it will not display anything because it's having a different baud rate. So I have to choose the baud rate as 9600. Okay, once I set the baud rate, it will display the hello world on the screen. Again, if I reset it, how many times I reset the controller is going to display the hello world on the screen, because I wrote this particular code in a setup. If I wrote this particular code in a loop, it's going to continuously repeat the sentences on the serial window. Another thing, like what's the problem with baud rate? If I'm sending at 9600 and if I'm receiving at 4800, suppose, what will happen? So you'll get a garbage data at the receiver side. Once I reset, you will get a garbage. The same code is there, but you will receive the garbage data. That's why you have to configure the baud rate, transmitter as well as the receiver with the same baud rate. Again, it will display the hello world. Okay, so next is serial ASCII table. We can print the ASCII values on a serial window. So we'll see a program directly. So I will open the code. I will explain the code first. Here, under a void setup configured for serial.begin, set up a baud rate with 9600. Then it will print one line ASCII table and the character map. Again, one integer is defined. This byte is equals to 33. So it will start printing the ASCII values from 33. So here serial.write we have used this byte 33 in a decimal value it will print. Again serial.print this byte in hexadecimal value it will print. Then serial.print hex like this it will print. For octal it will print this byte in octal. For binary it will print this byte in a binary. Again, if this byte is equals to 126, then if it is true, then it will continue the steps. Otherwise, it will make this bytes plus plus. Okay, so we'll see by downloading the code. Again, select the Arduino Uno, select the COM port, and then come upload. Okay, it's uploading, done uploaded. Now I will open the serial monitor. Either you can go from tools, then serial monitor, or there is a shortcut available here. You can directly click on this particular window. You will get a serial monitor here. So again, this is printed on the console window. So you can look at this. So it will print all the values. These are the ASCII value of this. The 48, 0, 49. Suppose if you consider capital A is a 65, then small a is 97. Okay, all the ASCII values are there. Now there are different open source software tools are there for the serial window. So I'm going to demonstrate those as well. So we'll minimize this, maximize this. So first tool is, we'll see Putty. So Putty is the tool again for the serial window configuration. Again, we can have different logging. And Putty is very popular tool for like internet access or Ethernet access, or we can have SSH, or we can have Telnet or R login, remote login we can use via Putty. So we can do a serial configurations as well. So I will choose a serial. I will select the COM port. My COM port is 2. I can put a baud rate here. Speed is a baud rate. And if I open this particular port, it will open the Putty and then it's going to display the same code. Like the code is running on the hardware. This is the hardware I have connected with the PC. So this is the tool. You can download this particular Putty from the website known as Putty. So if putty.org is the website, you can download this particular Putty tool from this putty.org. The second tool is Teraterm. So you can download this Teraterm from osdn.net/Teraterm. Is an open source project from this osdn.net. Again, Teraterm is very good software tool. Again, it handles SSH and all. So we'll see the demonstration of Teraterm. So I will open the Teraterm now. Here again, first is a TCP/IP configuration. If we are not doing TCP/IP configuration right now, we are doing serial. So we'll select serial. It will detect automatically the port COM2, Arduino COM2, and then click OK. So once I hit OK button, you will get all the values are printed on the screen. The thing is, if your COM port is busy with any of the software, it's not going to handle with another software. So you have to close the previous software connection, and then only it's going to connect it with a new software connection. The very next tool is MobiXterm. This is very popular tool in case of serial communication. So it handles many things. MobiXterm, again, it is an open source tool. You can download the tool from mobixterm.mobatech.net. There is a download tab available. You can click there and then you can download. You will get different plugins as well, and this tool is very good. So I will open the tool and I will show you. MobiXterm. So this is the user interface of MobiXterm. So we have different sessions. We can control the servers. We can control different tools. We can have games. Then we can have sessions and weave, split, and all. So I will start a local terminal here. Sorry. I will create a session. So click on a session. So we can have a different sessions here. We can have SHS, Telnet, RSH, XDCMP, RDP is there, remote desktop, VNC is there, FTP is there, SFTP is there, secure FTP, serial is there, file, shell, browser, Mosh. Again, we can control with AWS, Amazon Web Services S3, and WSL, that is Windows subsystem for Linux as well. So we are doing serial. So we'll select serial. Now it's going to tell me to choose the port. So I'm going to choose the port as COM2, baud rate is 9600. If I click OK, it will be turning on the character map. You can view here all the characters will be displayed. The program serial monitor will be displayed here. So this tool is very good, and there are different functionalities. Many functionalities are there. You can download and you can check this tool. The tool name is MobiXterm. I will exit from the tool. I will disconnect it, and then I will exit. Another paid software tool is there, that is known as a Docklite. I will open the Docklite. I'll start with a blank project. Okay, then I'll choose a COM port, double click there, choose the COM number as 2. Okay, then I need to connect this. So this is the connection. So once I connect this particular thing, we'll receive ASCII values here. So this Docklite tool is a paid tool. We need to purchase the licenses for the Docklite tool. Again, there is limited functionality, but many of the industries are using this because it converts all the values in ASCII, hexadecimal, decimal, binary, and all. So these things are available with Docklite. Next, how we can plot different waveforms on serial window. So there is a software tool known as a serial plotter. With the serial plotter, we can plot different waveforms on the serial window. Here is the program. I'm going to explain the program first, and then I will show you the demonstration of serial plotter. Void setup, serial.begin 9600. So it will start with a baud rate of 9600. Void loop. Then I'm going to print first sinusoidal waveform and the cosine waveform as well. So sine angle is 0. So I'm going to change the angle from 0 to 90 degree with the angle change of 0.1 degree. Float sine of A is equals to sine of angle. Float cos A is equals to cos of angle. Then it is printing sine A, then space cos A, then end. Okay. We'll see the demonstration of this. This is a serial window program. I'm going to upload now the serial window program to the controller. So I will select Arduino Uno. Then I'm going to select COM2 as a COM port, and then I will upload this particular program. So once I have uploaded the program, there is an option available in the tools menu. So once has been done, I will show you. There is an option available, that is serial monitor and serial plotter. So if I observe the monitor, you will get numeric values in the monitor, but if you observe at the serial plotter, you will get plotting. So here, if I observe the monitor, you will get numeric values because these are the signed values. And you need to close this and then again go to tools and then serial plotter. We'll observe the plotting of the waveform. So very nice sine and cosine waves are printing. So like this you can print sine and cosine waves. So here I have selected baud rate and then the values. Next program is serial plotter with the Sawtooth wave generator. Again, void setup serial.begin 9600. Again, while in a Sawtooth is like incremental triangular wave, again decrease to 0, again incremental, and again decrease to 0. So what I have done is I have used for loop. Float I is equals to 0, I is less than equals to 90, I is equals to I plus plus, and I have delayed with 1 millisecond. So every time with 1 millisecond it's having new value and it's delayed, and again it's printed like this. So it will print line by line, and again once it's reached to 90, it's come back to the for loop, and this is under a while loop. That's why again I is 0. So again it comes down to a 0. Again it will start like this and this. So we'll do a demonstration of this. So I'll open the code. Here it is a Sawtooth code. Then I'm going to upload the code on the hardware by clicking upload button. Once it's uploaded, again we need to go to tools and then open this serial plotter. Done uploaded, go to serial plotter and look, this is a Sawtooth waveform is printing. So very nice graphs is printing. Similarly, we can have a triangular wave to be printed. So till that time I will start uploading the code and then I will explain the code. Here again I have a for loop for I is equals to 0, I is less than equals to 100, I plus plus, then printed an I with a delay of this. If it reaches 200, then I need to decrement it again. So again I is equals to 100, I is greater than equals to 0, I is equals to I minus 1, again is decremented. So like this, like this, like this, like this, it's going to print. So we'll see the output. Go to tools and then plotter again. So it has to print a triangular waveform. So it's printing triangular waveform. Similarly, we have a square waveform. So I will open the code for. So this is the square waveform. I will explain the code. For integer a is equals to 0, a is less than equals to 100, a plus plus, b is equals to 0, serial.println b. So it will print 0 for 100 millisecond, and then it will print 100 for again 100 millisecond. So once it will print 0 and once it will print 100. So I will upload the code and we'll test. Go to tools, again serial plotter. Once has been done, so uploading has been done, go to plotter. We'll observe the square wave as printed 100 0 100 0 100 0. After this UART, there is another serial interface known as an SPI. SPI stands for Serial Peripheral Interface. SPI is a protocol, uses 3 signal lines. Generally it is a 4-wire protocol. Slave select line is there, but some are having fixed slave select and some are having modified slave select as well. So what are these 3 lines are? First line is MISO. MISO stands for master in and slave out. Master in, slave out. The lines for the slave sending the data to the master device. So master is an input device and the slave is output device. In case of MOSI, that is master out slave in, the line for the master device is to send the data towards the slave, where master is sending the data toward the slave and slave is the receiver. SCK is a serial clock, a clock signal to synchronize the data transfer between slave and the master. So SPI interfaces available on Arduino Uno. So there are 6 pins available. That is, the pins are ICSP is written over that pins. The pins are like this. So this pin is MISO, master in slave out. This is 5V pin, MOSI, that is master out slave in. SCK serial clock is there. Then we have a reset pin and then the ground pin. So this is ICSP configuration of this. Generally, in case of Arduino Uno, the slave select line is available on digital interface of line pin number 10. Master out slave in line is available on digital in line 11. Master in slave out is available on digital line 12, and slave like serial clock is available on line number 13. There are some standard SPI functions available, like begin, which initializes the SPI interface pins to the Arduino, end, which terminates the SPI communication, set the bit order, that is mode, it sets how the Arduino sends the data out through the SPI interface, set the clock divider, in argument is a divider, sets the timing clock speed on the SCK interface, set data mode, that is it sets the data mode on the interface, and the transfer the value, it sends the 1 byte of a data out the SPI bus and retrieves 1 byte of data from the bus. The next very popular protocol is I2C, that is inter-integrated circuit bus. It is a 2-wire protocol. One wire is SDA. SDA stands for serial data access, and another wire is SCL, that is serial clock. It is a wire protocol. So there is a master and there are the slaves. So we can have one master, multiple slaves as well. So wires used in this I2C are 2. Maximum speed for the I2C is 100, standard mode is 100 kbps, and in case of a fast mode it is 400 kbps. In case of a high speed mode it is 3.4 mbps, and ultra fast mode it is having 5 mbps. So I2C is a synchronous protocol, then it is a serial protocol. Maximum number of masters available with this I2C is unlimited, and maximum number of slaves are 1008. This is the message format for the I2C. We'll see the message format. So we require to have a start condition, then 7 or 10 bits of address frame. So for the I2C, each and every slave is identified with its own address. Then read and write the bit, whether it's reading or writing from the slave, that will be notified with this particular bit. Then acknowledgement and negative acknowledgement bit. So once the slave is received or not received, that will be acknowledged with acknowledge bit. 8 bit of a data frame. Again, that data frame has been acknowledged. Again 8 bit of a data frame 2. Again that data frame is acknowledged here, and then the stop condition. So this is the message structure of I2C. Then there are few library functions available with I2C. So I2C uses wire library. So available, again it returns the number of bytes available from retrieval of the buffer. I2C begin. So in case of a begin, we need to pass address as an argument. A begin transmission with the address. It starts transmission session to the slave device specified by the address. End the transmission with the address again. End the transmission session with the slave device specification address. A read. It reads the byte of a data sent from the master device. A request from address and the byte. It requests the data from that particular address in terms of a bytes. On receive with a function. Calls the function when Arduino receives the data from the master device. On request, this calls the function when the Arduino receives the data from the slave device. Write data and the length. It sends the data in the transmission session with a slave device. Okay, so reading the analog values, as the Arduino is having analog inputs, so there are total 6 analog inputs with the Arduino, so we can read any analog values over those particular 6 inputs. So here these 6 inputs are located. Basically the Arduino is having 10 bit of ADC. So 10 bit of ADC means, so there is a big term resolution for the ADC is important. So ADC will do quantization every time. So if the number of bits of ADCs are more, then you will get more accuracy. So we'll see first the resolution term and then we'll go for the coding. So what is resolution? Resolution is the smallest possible change it can measure. So resolution formula is resolution is equals to V reference divided by 2 raised to n, where n stands for number of bits of ADC. So in case of Arduino, it's a 10. So V reference we have standard. So resolution R is equals to V reference we have standard as 5 volt. Then 2 raised to n, that is 2 raised to 10. So that comes around 5 volt divided by 1024. That comes around 0.4 millivolt. Means what? So it will change the smallest voltage change till 0.4 millivolt only. So if you go on increasing the number of bits, then the resolution will automatically increase or improves. But the second thing also you can do is decrease the V reference. But the standard V reference is 5 volt. So if you want to decrease the V reference, so there is a reference input available with Arduino. So you can do that a reference input, but that voltage should be a standard one, like constant one, regulated one. Okay, now we'll see the coding of this. Okay, here integer port, the port is defined with A0. So I'm going to connect a potentiometer to A0 input. Then initialize with the value 0. Void setups, I'm going to print the values of port on the serial window. So initialize serial dot begin with 9600 baud rate. Here is the command. Value is equals to analog read is the function which reads the value which is connected to A0. So port is A0. So it's going to read the analog value from A0 and then it is printing that value on the serial.println monitor. Again it is print a space and wait for 20 seconds. So we'll compile this. Once compiled, copy the hex file. Copied the hex file. Go to the Proti simulation. Here I have connected a linear potentiometer to the A0 input, and here it is a virtual terminal. You can set the configuration. I have baud rate is 9600. Number of bits I am sending 8, none, parity. Stop bit is 1. Click OK. Double click on this and then put the code path. Delete previous one. I will put a new one. Backspace. Click OK. After that I am going to simulate. You can observe that it's having a 10 bit of resolution, means maximum value, minimum value is from 0, so showing 1 till the maximum value is gone till up to 1023. So you can observe this is 1023, it's the maximum value. Okay, next is LDR. LDR stands for light dependent resistor interfacing with Arduino. So LDR looks like this. So LDR is a light dependent resistor. The resistance of LDR may typically have the following resistance. At the daylight it's having 5000 ohm, but during the dark it's very huge resistance. So the resistance with respect to a light intensity, if the light intensity goes on increasing, the resistance goes on decreasing. If the light intensity goes on decreasing, the resistance goes on increasing. So this is the LDR module. So LDR module comes with two different outputs. There is a 4 pins. One is VCC, second is ground, third is D0. So this is a data output pin. So we'll have a digital output. Also there is a A0 output pin. So here it is, we'll get analog output. So what are the components it's having? It's having one potentiometer and it's having one operational amplifier, that is op-amp. That is, they are generally using LM324 as a op-amp. I will explain the code now with the LDR. Integer LDR value. LDR value is equals to digital read LDR. So I have attached to LDR to pin number 3 and is going to read the digital value. If the LDR value is 0, then light is available. It will turn off the LED. Else you are in the dark, light is not available, it turn on the LED. We'll see the demonstration of. Here in the code, the LDR light dependent resistor is connected, module is connected to pin number 3. LED is connected to pin number 13. So I have configured the pin mode, LDR as an input, then LED is an output. So I'm printing on the serial monitor. So serial begin 9600, then serial.println welcome to light sensor. Then this code I have already explained. Here it is LDR value. It's going to read the digital value LDR. If it is 0, then light is available. If it is 1, then light is not available. So we'll see the simulation. So I'll open the simulation. Here it is I have taken a LDR. One voltage divider network is there. So from this point I have given the input to pin number 3. This is a terminal. Then this is the LED. So I will run this particular code. Now light is not available. So this LED is on and it's printing you are in a dark, light is not available. So I will move forward this particular torch. Once the resistance of this decreases, so it will give a 0 logic, then light is available. So it will turn off the LED. Okay, so next we have 7-segment interfacing. So basically there are two types of 7 segments available in the market. One is a common anode type of 7-segment display and a common cathode type of a 7-segment displays. So common anode type of 7-segment displays are having current sinking type of displays, and common cathode type requires current sourcing. So current sinking is always better, and because of that the manufacturing of common anode type of displays are more. Because of that the cost is also reduced. So common anode type of single 7-segment display you will get it around 4 rupees, but in case of common cathode type of a display you will get it around 8 to 9 rupees. So it's a double. So here this is the diagram where we'll have schematic of common cathode type of a display. In this all the cathodes are shorted and then that is connected to a ground. In case of common anode type of display, all the anodes are shorted and that is connected to +5. To turn on a particular digit or a particular LED, we need to send 0 command in case of a common anode, but in case of a common cathode, we need to send 1 command. So this is the segment structure. We have a center pin as a common pin. So we can either it is a common cathode or it is a common anode based on your purchase. So if it is common anode, we need to connect it to the +5. If it is common cathode, we need to connect it to the ground. Here it is A, B, C, then this is polarity pin, D, E, F, G and DP. So it is actually DP. So we have here A, B, C, D, E, F, G. This is the structure of 7-segment. How to calculate the numbers using common anode type of display? We need to write ABCD like this. So A2 dot like DP, and if I am using common anode type of display, to turn on that particular digit I need to send 0. So for displaying 0 I need to make only dot and G only off, rest of the things are on. So that's why 0, my code is C0. So like this I have calculated all the codes. So there are two ways we can program. So this is a circuit schematic. We'll see circuit schematic afterwards. So I will show you the simulation of this as well. Let's skip. Okay, before starting the common anode type of 7-segment display simulation, I will explain the code. Here I have assigned the pin numbers. This is segment A, B, C, D, E, F, G and DP. So I have assigned the pin 6, 5, 4, 3, 2, 1, 0 and 7. Again, I have configured all the pins as an output in the setup mode. So output, then constantly I don't need to display the digit, so I have made it 1. Then for code for 0, so for 0 all A to G, A to F are 0, so I am writing A to F 0, G is 1 and delay for 1 second. Code for 1 again 1, similarly code for 2, code for 3, code for 4, code for 5, 6, 7, 8, 9. So this is a basic code information. So I will simulate this code. So I have connected a common anode type of a 7-segment display with Arduino, and then these pins are connected. I will run this particular thing. You'll observe after a second it's going to change the display. It's 1 now, it's 2, it's 3, 4, 5, 6, 7, 8, 9, again 0 because it's in loop. Okay, so next we'll see a 7-segment after 7-segment display we'll see LCD, that is liquid crystal display. So there are basically a 16:2 LCD displays are commonly used, but we'll get 8:1. 16:2 means it's having 16 characters to be displayed on first line, and by 2 means it's 2 lines. So we'll have 16:4 as well, 20:4 as well, 64:4 as well. Then we'll have 8:1, 8:2. So these types of displays are there. So what are the features of this? It's capable of displaying up to 1 or 2. Then it's 8 characters lines, like we have 16 characters on one line. There are pin numbers versus positions. We'll see the pin starts with 1 from the left corner. This is 1 number pin and this is 16 number pin. So total 16 pins are there. Then it uses a controller HD44780 as a controller, and it is alphanumeric type of a display. So these are the pins of LCD. So pin number 1 is a ground, pin number 2 is VCC, pin number 3 is a contrast, pin number 4 is RS, RS stands for register select, pin number 5 is read or write, pin number 6 is enable, then pin number 7 to 14 are D0 to D7. So we can configure LCD in 2 different modes, like we can use it in 8-bit mode or we can use it in 4-bit mode as well. If you are using in a 4-bit mode, we need to use only D4, D5, D6 and D7. So last 2 bits are backlight. So pin number 15 is LED plus and pin number 16 is LED minus. To a battery operated, if you are using battery operated systems, then we can turn off this backlight. So light is off for that particular LCD. Now there are a few command lines and command words for the LCD. So this is a command instruction set. So to clear the display, there is a command 0x01. To return to the home is the starting position. The command is 0x02. For entry mode, the command is 0x06. For display on and cursor off, 0x0f. To select the display, 0x28 and all. So we can calculate any of the commands from this. So LCD is having at the backend side, the LCD is having 2 black dots. One dot is a processor and second dot is CZ RAM. CZ RAM stands for character generator RAM. So it's having all the ASCII table inside the LCD, and that ASCII table is mapped by using the processor. The program is written under the processor. So these are the commands we are going to use. So we'll see. This is the wiring connection diagram for the LCD. So I will give you the code first and then we'll see the simulation. Okay, so here is the command code for the LCD. So very first line, we have included a standard library known as #include liquid crystal.h. So many of the functions are defined under this particular library. This library is by default standard library and by default comes with Arduino IDE. Then I have initialized the pin numbers. So constant int RS I have connected to pin number 6, enable I have connected to pin number 7, D4 pin number 2, D5 pin number 3, D6 pin number 4 and D7 pin number 5. I have used LCD in 4-bit mode. So I have created one object, a liquid crystal, object name is LCD, and I have passed the arguments as RS, enable, D4, D5, D6 and D7. So void setup, inside that we need to write LCD.begin. So we need to choose which type of display we are using, like 16:2, 16:4 and so on. So I am using 16:2, so I will select it 16:2. Then it's print, lcd.print is the command to print the data onto the LCD. So it will print hello world. Under a loop, I am going to change the line number of the LCD. So there is a command lcd.setCursor. So this is the row and sorry, this is the column and this is the row. So on the first, 0th row is the first and first row is the second one. So we'll change this and then it will print the millis. So it will print the seconds over there, milliseconds over there. So I will compile this particular thing and then I'm going to chase. It's running now. So here I have connected RS to RS, pin number 7. Here I have used a labeling. The label is available here. So enable is connected to enable. RW I have keep grounded. Then D4, D5, D6, D7 are connected to 2, 3, 4, 5 respectively. And the LCD is printing. On the first line it prints hello world. On the second line it prints seconds. Suppose if you want to change the characters, then I'm going to change it here. Welcome technology. So I'll compile it again. If the characters are more than 16, it's not going to print. We'll see. I've not counted the characters, but it's compiled. So we'll get the message here as a done compiling. Still not, it's compiling. Done compiling. Now we'll taste it again. Here. Welcome technology. So last two characters it will not display. Okay, now we'll see a live demonstration of 7-segment display interfacing and LCD interfacing. This is the code for 7-segment display. I have uploaded the code on the hardware, so we can have the hardware here. All the lines are connected with the 7-segment, and then the segment is running. Look at this. Here is the LCD interfacing code. I have compiled the code and I have uploaded on the hard disk. I have uploaded on the hardware. So here it is Arduino, and the pins are connected to the LCD. So you can look at this. So it's printing hello world, and then the milliseconds at the second line. So once I reset this particular thing, so it will start counting from the 0. Started with the 0. So there is a contrast pot I have connected. Here it is a contrast pot. We can change the contrast as well. If you want more bright, you can do like this. Okay, the contrast we can change. So this type of LCD is 16 by 2 LCD. Then this wiring has been done, and that I have already explained in the before slides.